routers within the same autonomous system. That's the things I know about BGP. Thank you.
By the way, we can use BGP inside the company network as well, in the network, internal network. Anything else? Anyone else who know anything about BGP protocol? Or just tell me, guys, like we have already learned lots of routing protocol, OSPF, ESGRP, RIP. Then now why we are going to learn BGP? What is the need? Based on your understanding on routing protocol, you can share your experience, share your thought. Why we need one more dynamic routing protocol?
Maybe less administrative distance.
No. Even you can change the administrative distance value in OSPF, in EIGRP. In the last class, we had seen that.
Yes.
So if I will talk about the routing, how many types of routing we have?
Two.
Two.
Two types.
Static and
Dynamic.
dynamic. Again, in dynamic, we have multiple types of routing. How many types of dynamic routing protocol we have?
Two.
Two. Very good. Yes. First one is IGP.
Yes.
And the second one is
EGP.
EGP. So first one is IGP. And second one is EGP. IGP stands for Interior Gateway Protocol, and EGP stands for Exterior Gateway Protocol. Guys, may I know some example of IGP protocols? Like how many types of IGP protocol we have?
Like OSPF, ERGRP,
Yeah,
RIP.
RIP routing protocol, RIP, EIGRP, OSPF, and even ISIS. Later you will see ISIS routing protocol. This is also one IGP routing protocol we are using on internet side, on the service provider side. And EGP stands for Exterior Gateway Protocol. Now, can anyone tell me the difference between Interior Gateway Protocol and Exterior Gateway Protocol? Example of EGP can be BGP. Correct? What is the difference between IGP protocol and EGP protocol, guys? IGP protocol.
Same AS and multi-AS.
Yes. IGP protocol are the protocol which works within the ES. And EGP protocol is the protocol which works within the ES as well as between the ES. Right? Now question is why we need routing protocol between the ES? Why we need routing protocol between the ES? Anyone? Why we need routing protocol between the ES?
Of course, exchange the route.
Communication between different organizations.
Between different organizations. Very good. But between different organizations, we can perform redistribution as well. Is there anyone who know the disadvantage of redistribution, guys? Disadvantage of redistribution. Let's suppose I have
Metric.
router 1, router 2, router 3, and router 4. This is different organization. Let's say here I am running ES number 200 and here I am running ES number 100. ES is 100 over here. To make communication possible between ES 100 and ES 200, what we need? We need to perform redistribution on router number 3. Correct, guys? Correct. Till now, tell me router 3 is maintaining how many routing database? How many routing database? 2, one for ES number 100 and one for ES number 200. When you will redistribute ES 100 into 200, what will happen? It will inject all the routes of 100 into 200 process, right? In the same way, 200 routes into 100 ES 100 process. So routing table of R3 will increased. And guys, how many command you need to run on router number 3 to redistribute? A router, let's say here you are running EIGRPS number 100, here EIGRPS number 200. So you will run command router EIGRP 100, redistribute EIGRP 200 metric. Then router EIGRP 200 redistribute metric, redistribute EIGRP 100 and metric. Right? I need to run 4 command here. No problem. Right? Like this, we can make communication possible between ES100 and ES200. Now just assume there is another company, right? Here I am running ES number 300 and routing protocol is, let's say, EIGRP ES number 300, and these companies are connected like this. Now guys, here I have one router, here I have one router. Now on these routers also I am going to perform what? Redistribution. I'm going to perform redistribution, like you are going to redistribute ES number 100 route into ES number 200, and on this router ES number 200 route into ES number 300, and here also you will redistribute ES number 300 into 100 and 100 into 300. So there is chance that this company is going to redistribute same ES 100 route again to router number 2 to ES number 100, right? It will learn from ES number 200, then it will advertise to ES number 100, right? And this is what? Look, first issue of redistribution. Second issue, CPU utilization. Routing table of router will be increased. Third issue, difficult to configure, right? Like this, let's suppose you have 100 number of ES. So on 100 number of ES router you are going to perform redistribution, correct? There is chance loop can form in the topology. All routers are going to manage large database. You know, generally where we are using redistribution, guys, redistribution is good for connecting 2 or 4 small companies, let's say up to 5 small companies, and even not to advertise all prefixes. Like I have 2 companies, ABC and XYZ, right? I'm going to merge these 2 companies network together, right? In ABC company I have 1000 number of prefixes. In XYZ again I have 1000 number of prefixes. So out of 1000 number of prefixes, if we need to advertise only 5 number of prefixes from ABC to XYZ and from XYZ to ABC, in that scenario only you can use redistribution. Not everywhere. It will increase the CPU utilization of your router, right? Loop can form in the topology. So this is where we need EGP protocol, exterior gateway routing protocol, right? Let's suppose here I have 3 router, router 1, router 2, router 3. On router number 1 I am running ES number 100, here ES number 200, here ES number 300. So with the help of IGP protocol on all router we have to perform redistribution, right? But with the help of EGP protocol you can make communication possible between these 3 different organizations without the need of redistribution. This is where we need EGP protocol, exterior gateway protocol. An example of exterior gateway protocol is BGP. So today guys, in this video, in first class of BGP, we will focus more on why BGP. Until and unless you will not understand why we need BGP, it will be very difficult for me to teach you BGP protocol, right? So topic is why BGP protocol. Why we come up with BGP protocol? See, first reason, scalability, guys. IGP routing protocol are designed to maintain 1000 prefixes, 10,000 prefixes, 20,000 prefixes, not more than that. IGP protocol cannot manage more than 20,000 prefixes in your routing table. But guys, in real time, I have seen 9 lakh prefixes in the routing table of router, 10 lakh prefixes in the routing table of router, right, on the internet, on the service provider network. In that scenario, your IGP protocol will fail. IGP protocol will work smoothly with 1000 number of prefixes only. It cannot manage million of prefixes. And on the internet, there are million of prefixes, right? If you will search on Google, like internet, just type only internet on the Google, guys. Internet. See, these all hubs are your routers. Between 2 points, just see how many paths are available between 2 points. Between one source to one destination. Between one source to one destination, how many paths are available? See, let's suppose here I have one company connected with this router, right? This is a company. Here I have another company. See, between these two companies, how many paths are available, right? Can you imagine number of routes in this network? And these routes cannot be managed by your IGP protocol, Interior Gateway Routing Protocol. Here we need EGP protocol. Million of routes are available on the internet. Right? So first reason why we come up with BGP can be why BGP? Scalability. Right? Means BGP protocol can manage million of route in their routing table. Second reason, tell me guys, at least I am expecting few points from your side as well. Inter-domain routing, like as I told you, redistribution will, yeah?
CPU utilization.
CPU utilization, very good. Then BGP is good for scalability, BGP is good for reliability, BGP is good for stability, BGP is good for flexibility. Why Oza is joining now? Too late.
Sir, how about security?
Don't worry about the security. We'll discuss about the security later. Even we have seen how to configure authentication in OSPF. We'll see how to configure authentication in BGP. But there is no any difference in terms of security between IGP protocol and EBGP protocol, EGP protocol, guys. Interior and exterior. See, to manipulate the path, second reason can be a policy-based routing. Best reason, policy-based routing. Guys, to manipulate the path in IGP, in OSPF, EIGRP or RIP, how many options you have? You can manipulate the path with the help of offset list. By the way, offset list is also not recommendation, right? You can use the bandwidth, delay. In the real time, you will be not allowed to change the bandwidth, delay. In the OSPF, you can change the cost. You can use the summarization, route filtering. Hardly 3 to 4 options are there, right, for the path manipulation, for policy-based routing. Let's suppose a company have multiple connection to internet. This is my company, right? And I have multiple connection from service provider, right? if I will configure IGP protocol here, I will have very less number of parameters for the policy-based routing. Policy-based routing means, guys, what is the meaning of policy-based routing? Policy-based routing means how routers are going to perform best path selection, how routers are going to perform failover, how routers are going to perform route filtering, right? Means routing policies. What is the ES number? Autonomous system, the number of devices, group of devices or group of networks comes under single administrator or single organization. Why this is the definition of autonomous system, guys? Because the routing policy within autonomous system on the all router is going to be same, right? All routers are going to decide best path by using same process, right? So in IGP, hardly you have 3 to 4 options for the policy based routing, for the path manipulation. But in BGP, you have more than 12 attributes for the path manipulation. And as I told you, on the internet, see how many paths are available, right? So we need lots of attributes for the path manipulation, guys, on the internet, right? So that we can configure the routers, we can configure the path, we can configure the routing policies according to our requirement, according to the business requirement. Right? So BGP is very flexible for it, for path manipulation. You will see you have lots of attributes that you can use for path manipulation. Second reason can be policy based routing, like IGP protocols have very less number of parameters, attributes for the path manipulation. Third reason can be why we come up with BGP. Third reason, guys, tell me one scenario here. I have one router here, edge router R1. I have one network. This is my switch. Here I have some PCs and end devices, and these users want to access internet. What I can do, I can connect this switch to router and then router to internet. Let's suppose for the redundancy, for the load balancing, I have connectivity from two different ISP, ISP1 and ISP1 and ISP2. This is ISP1, ISP2, correct? On both ISP, there are servers. Let's say 8.8.8.8. Now, can anyone tell me how these users will access internet? Whenever this PC want to access internet, destination IP 8.8.8, source IP, private IP address, source MAC will be the MAC address of sender machine, destination MAC will be the MAC address of default gateway, will forward traffic to router. And on the router, to forward traffic towards internet, you will configure what? Default route? Default route? Correct? So let's say I have configured default route, that is 0.0.0.0 towards ISP1. That means router 1 will forward all traffic towards ISP1. You cannot configure two default route with same AD value on router to achieve load balancing. Here you cannot achieve load balancing even. If you want to share traffic between ISP1 and ISP2, or like this in the real time, you can have multiple ISPs, maybe 5 number of ISPs, and you want to perform load sharing. You cannot achieve load balancing with the help of IGP protocol here. Even between ISP and router, I cannot configure IGP protocol because ISP will be using different ES number. You will be using different ES number. Again, we have two types of ES number. One is private, another one is public. Like your IP address, IPv4 address. Remember, we have two types of IP addresses, right? Private and public. Private IP addresses are not routable on the internet. If I want to forward traffic towards ISP2, I can configure default route towards ISP2, right? I can configure the failover, like until and unless ISP1 is up, forward all traffic towards ISP1, no problem. I have configured the default route. But if ISP1 is down, then configure a default route towards ISP2 with higher AD value. Here I can set AD value 10. So if this link will goes down, or even you can track the ISP with the help of SLA, we will see it in the upcoming day. So what will happen in this scenario? If ISP1 will goes down, then your router will automatically shift traffic towards ISP2. That is fine. We can achieve the load balancing. But can I achieve load balancing here? No. But we can achieve load balancing with the help of which protocol? We can perform load sharing with the help of BGP protocol here. Done. So the third reason can be load balancing and failover, you can say. Load balancing and failover. Then fourth reason can be, just think guys, what issues are there in IGP protocol, because you have already learned all types of IGP protocol. Just think, what are the issues there? We come up with BGP protocol to overcome those all issues of IGP. Like as I told you, IGP can handle up to 1000 prefixes only. IGP protocol cannot manage more than 1000 prefixes. That means between companies we cannot configure IGP protocol. Let's say this is different company ABC again, and this is XYZ company, right? I want to merge these two companies together. Here we have 20k prefixes, here I have 30k prefixes. I cannot configure IGP protocol. Reason, here AS number is different, let's say 10, and here AS number is different. Even you know why you will not perform redistribution here. So for inter-domain routing, we have only one protocol, that is BGP, right? So to merge two companies network together, right? Or to advertise route to the service provider network, or to receive route from the service provider network, definitely we have to use BGP protocol, because my IGP protocol cannot handle lots of prefixes, right? So fourth reason can be, you can say, what? Inter-domain routing. Inter-domain routing. Fifth reason can be what, guys?
Yes, sir. Are you recording the section?
Sorry, bro. Thank you. Fifth reason can be, guys? Fifth reason can be, see, in the BGP, you will see BGP is much better than IGP protocol for loop avoidance, right? When we will start the BGP protocol, you will understand this. Don't worry. For now, just I am typing here. You can take one screenshot of these all points, because you are going to understand these all points in upcoming days. Loop prevention. Sixth point can be advanced routing or route filtering, right? Like in IGP, you have very less attribute for the route filtering. Even guys, while redistribution, let me give you one example here. Let's say here I am running EIGRP routing protocol, EIGRP, and in this company I am running OSPF routing protocol. Here I have one border router, ESBR router, right? So while redistributing EIGRP routes into BGP, how many options you have to differentiate the route, differentiate the external route? You can use the route map, you can add the tag value, that's it, right? You can change the metric type 1, 2. That's it, right? Only 1 to 2 options are available to differentiate the route or to filter the route. In OSPF domain, I can filter the route with the help of tag value. Like while redistribution, I can add the tag number 20, right? And with the help of that tag number, I can filter the route in OSPF domain. That is fine, but I have only one option, right? But in BGP, you will have lots of options. More than 12 attributes are there, guys, in BGP. Why it's changing automatically again and again? Don't know. So you can say advanced route filtering. I will have lots of option for route filtering in case of BGP. Next reason, seventh reason can be you guys are not familiar with traffic engineering, right? But when you will learn the traffic engineering, you will see BGP is much flexible with traffic engineering as well. Traffic engineering means engineer the traffic, right, in the network. Eighth reason can be, see, while redistribution is a very slow process, guys, right? Means whenever we are redistributing EIGRP into OSPF, routers take much time to update their routing table, right? So convergence is very slow while redistribution, right? But in case of BGP, convergence will be faster as compared to IGP protocol. So we can include that point as well, but I am leaving it. Then BGP protocol support both IPv4 and IPv6. Even you can configure OSPF also support both. Then in BGP we have some community attributes as well. Attributes. Ninth reason, most important reason, BGP is the only routing protocol which is TCP based protocol, right? So BGP is a completely reliable routing protocol. Guys, EIGRP is also reliable protocol, but how? Is EIGRP using TCP at transport layer? No. EIGRP using third party, right? Different protocol for the reliability, correct? That is RTP. But your BGP is TCP based protocol. BGP is the only protocol which is TCP based, right? So you can say BGP is a completely reliable protocol, right? BGP works at application layer and it uses TCP at transport layer. That means all messages in the BGP will be unicast only, because guys, TCP does not allow multicast, right? TCP does not support multicast, you can say. And before sending the actual message of BGP, router have to establish TCP connection. As you know, all TCP protocol first establish a connection before sending the actual data, correct? Like if your machine want to send HTTPS request message to Google server, first your machine have to establish a logical connection by sending SYN message, then server will send SYN plus ACK message, then your machine will send acknowledgement message. After three-way handshake process, your machine will establish a logical connection, then it will send the actual data. Am I right? In the same way, two routers will become neighbor in BGP after forming TCP connection, right? All IGP routing protocols support dynamic neighbor, right? How you are configuring OSPF between two router, guys? R1, R2. Once you will advertise this interface in OSPF, this router will start sending hello message. Once you will advertise this interface in OSPF, this router will also start sending hello message. And both routers are going to match some parameters. If parameters will match, both routers will become neighbor. This is what? Dynamic neighborship, dynamic in nature. In case of BGP, you cannot configure dynamic neighborship. In case of BGP, manually you have to configure neighbor IP address. You have to tell to router number 1 who is your neighbor. In the same way to router number 2 who is your neighbor. Any question till here? Any sort of confusion, guys?
Sir, I think the BGP TCP port number 179.
Correct.
Am I correct?
Correct.
Thank you.
Between
Yes,
two
sir.
routers, one router will use BGP port number 179 and one router will use random port number. But before talking about the BGP protocol number or the basic points about BGP, try to understand why we need BGP and where we need to configure BGP. Like again, see, BGP is slower than OSPF protocol. OSPF is much faster protocol than BGP. So for our internal network, BGP is not good, right? Even we can use the BGP inside my network, right? Let's say this is my company and my internal network is this. We have some access layer switches and all end devices are connected with these access layer switches. Then I have some distribution layer switches. All access layer switches are connected like this. I have some router. I have some firewall. This is my internal network, right? Here we should only configure OSPF routing protocol. OSPF is faster than BGP, right? What is the use of OSPF, guys? OSPF find the shortest path and the fastest path, right? In the same way, I have another branch somewhere, right? Maybe in different country. There also I have one firewall, right? And both companies are connected with internet. Both internet are connected with each other. Both ISP. This is ISP1. This is ISP2. Now between these two companies, I can create virtual network, VPN. Over the VPN also, we are going to use what? OSPF only, right? Then Praphul, where we will use BGP? So within the company, we will use what, guys? OSPF routing protocol only, IGP routing protocol only, right? Now let's take one example of a large company like Amazon. Guys, Amazon or Google have data center all around the world. Am I right? Amazon have their data center all around the world, right? And what company want? That my user should access the server as soon as possible, right? As soon as possible. And see, these are the data center of, let's say, Amazon. And Amazon will be using lots of ISPs, right? Amazon will have connectivity from different types of ISPs. So how Amazon is going to share routes between ISP and their internal network? With the help of BGP protocol only. How Googles are going to share prefixes with different service provider? With the help of BGP only. Right? So this is why BGP. Now soon we are going to understand where to use BGP as well, right? Then I will start what is BGP. Clear? Any question till here, guys?
Yeah, sir, can you repeat last point?
Yeah, here I have written everything. See, why BGP protocol? What is saying? BGP was developed because IGP protocols like OSPF, EIGRP, RIP could not handle the challenges of routing between different organizations on the internet. Because if you are connecting different organizations together, definitely there will be lots of network information that can be not handled by IGP protocol. BGP provide scalability, flexibility, and control needed to manage the complex interaction between autonomous systems, ensuring efficient and reliable routing across the global network. One second. IGPs are good for redundancy within within autonomous system. You can use the OSPF routing protocol, and definitely we are using OSPF routing protocol only, guys. OSPF is the most commonly used routing protocol in real-time network. Everywhere you will see organizations are using OSPF, right? So first you should have good command on OSPF routing protocol, then only you can survive in the industry. then only you can get huge hike in your salary, then only you can grow your professional life. And the second routing protocol is BGP, where you need command, good command. So to work on the real-time network, you have to master these two routing protocol, OSPF and BGP. Generally, OSPF for internal network to find the best path, shortest path, and BGP between the organizations. Right? When you will work on service provider networks, you will see lakhs of prefixes, lakhs of routes in the routing table of router. If you will run show IP route command, or if you will check how many routes are there in the routing table of router, you will see 10 lakhs of prefixes are there, right? A router can manage million of prefixes in the routing table, guys. Right? So IGP is good for redundancy within the ES, and BGP became the go-to protocol for managing connection between different autonomous systems such as ISPs and large organizations. Between ISP, definitely we will use BGP routing protocol only. Why BGP was created? For scalability, for policy-based routing, as I told you, for load balancing and failover, for interconnection between different networks or between different autonomous systems, for redistribution. What do you mean by redistribution? Redistribution allows two different routing protocols to share routing information. For example, one AS is using OSPF and the other is using EIGRP. Redistribution can be configured so that the route from one protocol are shared with other. This way, two ASA can communicate without needing to use same routing protocol. Right? With the help of redistribution, you can make communication between two different routing protocol. Otherwise, if there is no redistribution, then you have to replace the routing protocol in one company, right? Like maybe in one company you are running OSPF, in different second company you are running EIGRP. Then you have to replace maybe EIGRP configuration from the all routers in the second company, right? Scalability, like as I told you, BGP can handle lakhs of prefixes. And while redistribution, see, what is the role of scalability, guys? Redistribution in case of IGP protocol. Redistribution works fine for a smaller network, but it can become complex and difficult to manage as network grow. Redistributing route between different IGPs can result in large routing table that consume more memory and processing power on routers. It can increase the CPU utilization of router, right? So we cannot perform lots of redistribution in the network. Between 100 companies, if you are thinking that we'll perform redistribution 100 times, no, brother. So we come up with BGP to overcome this issue. Then policy control and flexibility. As I told you, while redistribution in IGP, you have very less options. You can add the tag value, you can use the route map, right? But in case of BGP, you will have lots of attributes. While you can apply basic policies during redistribution, like route map, the control is limited compared to BGP. Even we can do the redistribution, but we have limited command, limited control. And BGP offer much more control over routing policies. It allows you to define very specific policies for routing decision based on multiple factors like AS path, path attributes, AS path, route preference, and many more are there. This flexibility is essential in scenario where you need fine control over how data enter and exit your network. Like let's say in my company there are two exit points. Two exit points are there, right? To let's say go on internet. This is my company, there are two router, two is router, right? Through these 2 points, the user can go outside, maybe on the internet or to the other company. So in the BGP, you have lots of options to control this exit point. Maybe I want to forward critical traffic from this exit point, from this order R1, and the normal traffic from R2. R1 is, let's say, connected with ISP1. R2 is connected with ISP2. Right? I can forward critical data via ISP1 and normal data via ISP2, which is not possible with IGP protocol. Got it, guys? Then inter-AS connectivity, route filtering and security, convergence time. As you know, redistribution is very slow process. Now here is one example of a real-time company. You can read. What is autonomous system number? Hope you all already know the AS. What is autonomous system number? What is AS, guys? Autonomous system is a group of IP network or devices that are under a single administrative domain and share a common routing policy. In simpler term, what you can say, an AS is a large network or a collection of network managed by a single organization, such as a company or an internet service provider or a university. A university can have multiple branches, one branch in Delhi, one branch in Mumbai, one in Bangalore, one in Ahmedabad, Pune, right? But the routing policy on all branches will be same, right? So the entire networks come under single AS. And what is AS number? To identify the autonomous system, to identify the domain, like, guys, society. How we identify in which society do you live? With the help of name of that society. In the same way, to identify the AS domain, we have what? ASN, AS number. Each AS is identified by a unique autonomous system number. This number allows the AS to communicate with other ASs on the internet. When data move between ASs, BGP uses these ASs to determine the best path. BGP uses ASs to determine the best path. Like, this is my source network, ABC, destination network, XYZ. Between these two companies, there are multiple service providers. Multiple service providers are there, right? And all service providers are directly connected with each other like this. Like this only, guys, service provider will be connected with each other in real time, right? Let's suppose this service provider is using AS number 100, this service provider is using AS number 200, 300, 400, 500, 600, 700, right? All are different ISP, all are using different AS number, right? And now my companies are connected with this service provider like this. So BGP is going to find best path on the basis of list of AS, right? Through this path, let's suppose in my company my AS number is 1000 here and here 500 or 2000 AS number. So whenever company ABC will advertise any prefix to XYZ, let's say ABC have one prefix that is 10.1.1.0/24. So ABC company is going to advertise this network to XYZ. Now tell me, how many exit points are there? How many exit points are there to out from ABC to XYZ? 3 exit points are there, right? First of all, in BGP, you will have lots of control to manipulate the exit point. If you want to use this point, no problem, you can use this point, no problem, you can use. Even you can use multiple points according to your requirement. As I told you, I want to out a critical traffic from this point, normal traffic from this point, and this point is for backup. I can configure the scenario like this. By default, ABC company will advertise 10 prefixes to XYZ. XYZ will learn 10 prefixes from 3 different ISP, right? And guys, whenever a router advertise prefixes to their BGP neighbor, it include ES number. In case of eBGP, as Behzad told, there are two types of neighborship in BGP, iBGP and eBGP. Yes, Behzad? Am I right?
Yes, sir.
So
Yes.
whenever router will advertise prefixes or update message to their eBGP neighbor, it will always include ES number. So when XYZ company will receive route from this path, how many ES number will be there? 100, 1000, 200 and 300. Maybe XYZ company will receive same route from this path as well. Like this. But the number of ES will be more as compared to the upper path. So on the basis of ES, router can select the best path, right? Means via upper path, there are three different ESAs. Means routes are coming from three different ESAs. From the lower path, routes are coming from 5 ESAs. And lower ES number is preferred, best. This is the by default behavior, right? Then guys, routing policy. See, as I told you, routing policy means path selection. How routers are going to select the path, prefer path. How you are going to configure the router to consider ISP1 as the primary ISP, ISP2 as the secondary ISP. Those things are what routing policy only. How you are going to configure load balancing, right? So if these policies are same on a multiple router, that means those all multiple routers belongs to same autonomous system. Correct? What happened between autonomous system? So when traffic need to move from Amazon network to another network, say the customer ISP, BGP comes into play. BGP uses routing policies to determine the best path for the data. For example, Amazon network might prefer to send data through ISP A to reach customer ISP, but if the route is congested or down, it could be use ISP 2. Yeah, this is the very simple definition, like what it's saying. This is a company, data center of Amazon, and this Amazon have connectivity from two service provider, ISP A and ISP B. So BGP have capability to sense the ISP, right? If ISP 1 is up, BGP will forward all traffic towards ISP 1. If ISP 1 is not working fine, A is not working fine, automatically BGP will forward traffic towards ISP 2. Even we can achieve this with the help of IGP routing protocol. Yes or no, guys? But between ISP and your internal network, you cannot configure the IGP protocol, like, because ES will be different there. The then difference between IGP and EGP, you can read these things. I think you already know these all basic things. Like IGP protocols are used within a single autonomous system, and ES is a network or group of networks under a single administrative control, like a company internal network. eBGP, like BGP protocol, are designed for routing between different autonomous systems. These are networks owned by different organizations or different ISPs. Why IGP like OSPF were not enough? Why OSPF was not enough, guys? Because OSPF is an IGP protocol, and IGP protocol can manage thousands of prefixes only, right? Not lakhs or million of prefixes. So OSPF work well within a single ES, but struggles when dealing with vast number of routes that exist between different networks on the internet. OSPF was suffering in those type of scenario. OSPF and other IGPs rely on having a complete view of network which can lead to excessive resource consumption and slow convergence time when scaled to the size of internet. Like internet is growing, right? Every day we are adding lots of routes on the internet, guys, right? And IGP protocols cannot handle large number of routes. So these are the benefit of using BGP here. Now hope it is clear why we come up with BGP, right? You have many more a strong reason. So if interviewer will ask you or anyone will ask you why we come up with BGP, I am expecting guys you can explain them. Any sort of confusion till here? Any doubt? Because now you are going to understand where to use BGP routing protocol, where to use BGP multi-homing. How many of you know multi-homing? Second topic is where
Yes.
to use BGP. Yes, guys, can anyone tell me few examples where to use BGP?
So when we have two ISPs
Very good. Then,
and, and redundancy of the routers,
okay, great.
Large network over the internet.
Yeah,
so when we want to manipulate incoming and outgoing traffic,
correct. Very good. Anything else?
When we have to connect different network over the internet.
Good.
Inter-AS routing, sir.
Inter-AS, very good.
Sir, so I see a example multi-home networks. So what is meaning of multi-home networks?
Yeah,
Can you
soon,
explain?
soon, soon we are going to discuss. Don't worry. Don't worry.
Okay, sir.
When our network is large enterprise, in that scenario, we will use BGP routing protocol. Reason, IGP protocol cannot handle lots of prefixes in their routing table. Then guys, when we are
In
service
cloud,
provider, we can say, when we are service provider, in the service provider network, we will use BGP. The reason, service provider is going to provide what? Connectivity between 2 points. Let's say I have one branch office in India. I have one branch office in India or in Mumbai, India. And I have another branch office in same country in India at different city in Delhi, right? I need connectivity between these two companies. Like here I have one router, edge router, here I have one router, edge router. Guys, generally this router is known as by CE router, customer edge router, right? I am customer, right? This is the network of customer, and my edge router will be known as by CE router. This is customer edge router R1. R2 is also what? Customer edge router. See, and there are two types of provider. One is SP, who will provide you connectivity only, service provider, and another one is ISP. The difference between SP and ISP is SP will provide you only connectivity between two sites. Like you can see between Mumbai and Delhi, I can purchase connectivity from service provider, from SP. But if I need internet, then I have to go with ISP. ISP is the service provider who is responsible to provide internet service, right? So for now, here I want to make communication between these two sites. Let's suppose this is in Mumbai, this is the headquarter. And guys, in the headquarter, I have one server where I am running a very critical application. I'm running one application. I have hosted one application on this server. And all my your employees should be able to access this server, this application. So what we need connectivity between these two sites. So I can purchase the connectivity service from SP, from the service provider. What service provider will do? See, service provider have already their infrastructure between Mumbai and Delhi, right? They will have already one infrastructure between Delhi and Mumbai. Lots of router will be there, R1, R2, R3, R4, like that, right? R5, R6. There will be multiple paths between source and destination, between 2 points. As I shown you the internet. On the internet, there are multiple paths between 2 points, between 2 sites. In the same way, in the service provider network, we will have multiple paths. And these all routers are known as by P router, provider routers. These are provider routers. So if I need connectivity from this SP, this service provider, what we will do? We will purchase the connectivity, then service provider is going to connect my CE router to their router, to their edge router, right? And that router is known as, guys, PE router. PE router, provider is router. In the same way, here also service provider will have one PE router, provider is router, right? And they will connect PE to CE. This is one customer network. Like me, service provider will have million of customer, lakhs of customer. Correct, guys? Now let's suppose in the headquarter in the Mumbai branch, I am running 10 subnet. 10 number of subnets are there. So I will advertise, this CE router will advertise all 10 number of subnets to PE router, and then PE router is going to advertise those all subnets to other PE router, right? This PE router. And now this PE router is going to advertise prefixes to this CE router. This is how Delhi branch will receive all routes of Mumbai branch. In the same way, from the Delhi, I will advertise all prefixes to this PE. This PE will advertise this through this PE. This PE will advertise to this CE. And see, now service provider is managing 10 number of prefixes in Mumbai and 10 number of prefixes in Delhi. So it is managing 20 number of prefixes. And like me, if let's say this service provider have provided connectivity to 100 customer, so how many prefixes are there, guys? 2000, right? 2000 prefixes are there in the routing table of service provider routers. Correct? So service provider is not going to use IGP protocol. Definitely it will be using EGP protocol, exterior gateway routing protocol. And between PE to CE, which routing protocol I will use? Tell me, between PE to CE. Can I use OSPF? Answer is no.
Yeah.
We cannot use OSPF because again, guys, service provider, PE router belongs to service provider network. And definitely service provider will be using different ES number, right?
Got it.
So here also we will configure only BGP protocol, right? So whenever we are service provider, we will use BGP in the service provider network. Between PE to C means between provider edge to customer edge, we will use BGP protocol. Between two service provider also we will use what? Like this. This is one service provider, which is, let's say, Airtel. Airtel is a service provider in India, right? Like this, the another service provider is Tata. These two are service provider in India, guys, right? So service provider networks are also directly connected with each other. So between service provider network also we will be using what? BGP routing protocol only. Correct? So when we are service provider, third, between service provider networks, then between service provider network, means, like as I told you, this is Airtel, right? Airtel have lots of router in their internal networks and they are using, let's say, AS number 100. In the same way, another service provider is Tata. Tata have also lots of routers in their internal network. right? They are using AS number 200. So between Airtel and Tata, between these two ISP, we will be using BGP routing protocol only. Remember the one topology of EIGRP. In guys EIGRP, we had merged network of two different company, correct? Am I right? We had merged the network of two different company, ABC and XYZ. And in that scenario, I had redistributed route on both edge router. And you will see in the same scenario how we are going to use BGP and how easy it will become, right, when I will use BGP there. So between different companies, between different service provider, between different internet service provider, we will be only using ISP. Then guys, the next scenario, to understand the next scenario where we need to configure BGP, you have to understand customer network. Like how customer network looks like. How many types of customer networks are there? Customer networks means like my network. As I told you, I have headquarter in Mumbai. So you know the basic design, access layer switches, distribution layer switches, core routers, firewall, right? These are the basic structure of network. This is what? This is my internal network, right? This is my internal network. Now to access internet, I have to connect my network to internet. I can connect internet like this also, right? But there is no any redundancy, correct? I can connect two cable for redundancy. But still, see, I have redundancy for cable, but for ISP, we don't have redundancy. We have still one connectivity from one ISP. What if ISP will goes down? So I can purchase connectivity from two different ISP. We can use two links. So these are what? These are customer networks, different types of customer networks. And customer networks type depends on our requirement, on the requirement of organization. A startup company can have simple this network, switch, one router and ISP, right? A startup company can have this network design, right? But is this design sufficient for enterprise company, guys? If you have something very important in your internal network, if you have critical application in your network, no, because there is no redundancy. So to understand customer network, types of customer network, let me tell you about multi-homing. And someone had asked this question as well, like what is multi-homing? So see bro, what is multi-homing? Connecting a network to or more internet service provider for redundancy, for load balancing, for improved reliability. Multi-homing provides benefits such as continuous internet access even if one ISP fail, and it allowed network engineers to optimize traffic routes based on the performance, cost and other factors. So how we are going to optimize the network? According to our requirement only, right? You have to identify. See, suppose you are a network engineer in a company. So bro, the first thing that you need to understand about that organization is what is the priority for that organization. Cost can be the priority for that organization. Maybe if that organization is a startup, they cannot invest much money on their infrastructure, right? Availability can be their priority, like internet should be available every time 24/7. There should be no downtime. Then your network design is going to be different. Security can be the priority for a company like Amazon, guys. See how important security is for the Amazon, right? What if I will hack the Amazon network and I will set price 0 rupees to all product? Right? Guys, what is happening in the Amazon? There are server in the network of Amazon. On the server, they are running application, right? On the application, what services are there? Products. For each product, they have defined a price. What if someone will set that price to 0? correct? What if someone will change the address? Let's say you have ordered something from the Amazon, you have ordered one Cisco router. By the way, I think Cisco router is not available on the Amazon app, but let's suppose you have ordered the Cisco router, right? You have made the payment, you pay to Amazon, and now I have hacked the network, hacked this server, and now I'm going to change the address. I will change your address to my address, not whom Amazon is going to deliver, to my address, correct? So you have to understand the priority for the particular organization, right, where you are working, where you are network engineer. According to that, you are going to design network. So better example can be, let's suppose a company has one data center here, DC data center, and one branch office. Branch 1. Branch 1. Guys, see, this company have multiple branch offices like this. Let's say 10 number of branches are there around the world. But company cannot afford one firewall at each branch office. So they will place firewall at data center only. And in the data center, they are hosting one application. Correct? Now they need to connect data center and branch office. Right? Multiple transportations are available. Generally, most of the organizations are using MPLS because MPLS is very reliable transportation, right? Very secure transportation, right? So they can purchase MPLS connection. Now the branch office and data center can communicate with each other. But can branch users or user from the data center access internet? No, right? So they need what? Internet connection. So let's suppose they have purchased the internet connection as well, like this, internet. Right? Now there is one user in the branch office 1. Guys, tell me, can this user access internet by using this link? No. We'll never configure the scenario, this router, so that the user from the branch office will access internet directly, because here I don't have firewall. I cannot configure the policy on router, right? That means anyone can reach to internet, and anyone from the internet can reach to my internal network, right? They can attack, they can perform the attack. So we'll configure the scenario in such a way so that whenever a user will try to access internet, first they will go to headquarter via MPLS. Now on the firewall, we will configure the policies. Firewall will verify the policies, like if firewall will check, who are you? Are you allowed to go to reach internet or not? And which type of traffic you are sending? Let me check. This service is allowed for you or not, right? If it is allowed, then only it will forward traffic to internet. And in the same way, it will get reply message. They can communicate like this. So these type of scenario, like all scenarios, depends on our requirement only, right? At the same time, another company can afford one firewall here, right? In that scenario, branch users can directly access internet. Right? So everything like your network design, your network configuration, choice of protocol, choice of security configuration, policies, everything depends on our requirement. According to the requirement, we are going to decide the devices, which devices we will purchase from the market. Because see now, in the market, like Cisco is a manufacturing company, and Cisco have developed, guys, many devices, right? Many types of router are there in the market. Why we have multiple types of router? So that we can purchase according to our requirement. Why there are lots of mobile in the market? So that we can purchase mobile according to our requirement. Like someone are looking for mobile where security feature is excellent. Someone is looking for the mobile where CPU is the best. Someone is looking for the mobile where, let's say, hitting is very low, right? Someone is looking for mobile, right, which takes very less time to charge. In the same way, to design a network, to implement a network, we are going to choose the hardware as well as software according to our requirement, right? And multi-home is a process which tells how you are going to connect your internal network to internet service provider. And the type of multi-homing, how many types of multi-homing are there, guys? Single homed ISP. If you want to see the diagram of single homed ISP, let me show you here. This one, single home network. So this is for the small organization, guys. This is for a small organization. Here we don't have redundancy. You can see for internal network and external network between my internal network and ISP, right? So single home is the simplest setup where a customer network connects to only one ISP, one internet service provider. Example can be a small business with basic internet need might connect to a single ISP. There is no redundancy in this setup. So if the ISP experience an outage means ISP goes down, ISP is not working fine, users are not able to access the internet. So at the time of outage, business loses internet access. Business loses internet access. Then guys, second type of homing is dual home. Dual home means multiple connection to same ISP. Let me design the diagram. ISP, internet, router, switch. I'm not talking about the internal network. Internal network can be anything, like you can have multiple distribution layer switches, multiple access layer switches, right? And then end devices. Now in this scenario, I'm going to connect internet to this router. This is which type of multi-home, guys? This is single home network, correct? In the dual home network, what we will do? We will add one more cable here. Now tell me, in the single home design, should I configure BGP here, guys, on router? Should I configure BGP? And see, all routers are not going to even support BGP. Like right now, I am expecting you all have broadband router at your home, right? Through which you are accessing internet. Am I right? Am I right? Guys, are you using BGP routing protocol at your home router? No. And is BGP required there? Definitely no. BGP is not required there, right? Because there is only one path, one ISP. I can configure the default route. That's it. So in single home, BGP is not required. In multi-home, if we have two connections, is BGP required?
Yes, sir.
Here R1 will use one default route only, right? Either it can use default route via this link or via this link. R1 cannot use both link. So if you want to utilize both link, maybe you want to perform the load balancing, you can use BGP protocol. Only BGP is the option, right? Only BGP is the option in this scenario. Now guys, third type of homing is multi-home. This is dual.
Yeah, yes, sir. Why is the BGP only option for here?
To achieve load balancing.
Achieve?
Load balancing.
Okay.
To forward 50% traffic on this link, 50% traffic on this link. There is no any other routing protocol which can perform load balancing here in this scenario, right? So this is, guys, dual homed. Then we have multi-homed. See, in this scenario, what is the issue? In earlier scenario, what was the issue? There was only one cable, one ISP. In this scenario, we have two cable, between ISP and my edge router, but we have single ISP. Correct? So this network design is for medium size organization, right? Single homed is for small organizations, like for your home, so that all family member in your family can access internet. You can configure single homed. Dual homed is for medium size business, right, where you can connect two link with same ISP. A customer network connects to a single ISP using multiple links, 2 links or more links. This provides some redundancy but does not protect against a complete ISP failure. Example, a medium-sized business might have 2 fiber connections to the same ISP. If one link fails, traffic can switch to the other and we can achieve the load balancing as well. But if the ISP goes down, the entire network will goes down, right? Internet will goes down. So that's why we have come with third types of homing, that is multi-homed. In the multi-homed, you will have connectivity from different ISPs. And guys, this type of network is for enterprises company where you are going to work. Where you are going to work. So if I will give you example of multi-home, so multi-home design can be like this. I have one router, edge router. This router is connected with LAN. Then I have connectivity from two different ISP. ISP1, ISP2. And here we will run BGP protocol. So the customer network connects to multiple ISPs. This provides redundancy at the ISP level as well as at the link level, right? So if one ISP will fail, traffic will still route towards other ISP. Got it, guys? Here we can perform load balancing by using BGP protocol. Definitely you will use BGP in this scenario, right? So here you have redundancy at ISP level. So if one ISP fails, traffic can be routed through the other. Example, as I told you, enterprise. A large enterprise or data center might connect 2 or more ISPs using BGP, right? Even in the dual home, you cannot configure the BGP. You can configure the default route, 2 default route, right? Most of the time, guys, we are configuring default route in dual home as well. Because to run BGP, you need high configuration router, right? You need good memory, CPU, right? So your device is going to be costly. So if your company is like medium size, then you can purchase the normal router and you can configure the default route. But still you have option to configure the BGP. You can configure BGP as well, right? In the multi-home, we will
Can
be
we
using
configure?
BGP only.
Can you configure BGP on firewall?
Yeah, you can configure BGP on firewall as well. Yes, you can configure BGP on firewall as well. Multi-home. Multi-home means multiple ISPs. And in this scenario, you have redundancy at ISP level. A large enterprise or data center might connect their network to 2 or more ISP using BGP. If ISP A goes down, traffic automatically shifted to ISP2, ensuring continuous service. Multi-homing also allow for load balancing and cost optimization between ISP. Cost optimization for ISP means, guys, let's say I have connectivity from 2 different ISP. ISP1 is more reliable, right? ISP1 have more bandwidth, right, as compared to ISP2. But ISP1 is very costly. ISP1 is very costly and ISP2 is very cheaper. So with the help of BGP, what we can do, we can forward only critical traffic towards ISP1, all rest traffic towards ISP2. So we'll purchase less bandwidth from ISP1 and more bandwidth from ISP2. Like as I told you, there are two service providers in India, Airtel and Tata, and like that there are not million, many service provider. In the same way, for the internet service provider, right? In India, Jio, Airtel, Vodafone, right? These are ISPs who is providing internet service provider, right? Maybe Airtel is costly to Jio, but Airtel is more reliable than Jio. So I can use both ISP, but Airtel only for the critical traffic. And BGP is the only routing protocol which will allow to configure scenario like this. BGP is the only routing protocol which will allow you to configure scenario like this. Correct? So here we can optimize the cost between ISPs. Then the last type of homing is dual multi-homed. Guys, what is the problem in previous design? My edge router is connected with two different ISP, ISP1 and ISP2. What is the issue in this scenario? Issue is we don't have redundancy for edge router, right? What if this edge router will goes down, or if this link will goes down? Correct? So a mission critical application will not use this design, right? So that's why we come up with four type of design, that is dual multi-homed. In dual multi-homed, the most robust setup where the customer network has multiple connection to multiple ISP, multiple connection to multiple ISP. This provide maximum redundancy and flexibility. Example, a global corporation with mission critical application might connect to two or more ISPs with multiple connection to each ISP. You can have multiple, like from ISP1 I have two connection, right? From ISP2 also I have two connection, not only one connection for one ISP. We can have multiple connection from one ISP. This setup ensures that even if one ISP and one link fails simultaneously, then also network remain operational, right? So if ISP will goes down, link will goes down, then also no problem at all. And design can be like this, guys. My internal network is R1, R2. Here I have subnets. Here I have subnets. Subnet means distribution layer switches and access layer switches. Now two ISPs are there, let's say ISP1, ISP2. In your scenario, in real time, you will have more number of ISPs, right? 4 ISPs, 5 ISPs, and I'm going to connect like this. So see, in this scenario, if ISP1 will goes down, no problem. Even if ISP1 and this link will goes down simultaneously at the same time, no problem. Even in this scenario also we can distribute the traffic, right? Some user can reach to ISP2 via router number 1. Some user can reach to internet via router number 2 to ISP2, right? So here what we can do, the biggest advantage of this design is here we can distribute the traffic, right? If you have only one router, then all traffic will reach to internet via that router only, right? So guys, in the real time, when you will work as a network engineer, maybe you are going to work on this type of network or dual homed network, right? And now if you are thinking, Praphul, now we have two default gateway. So users, how users will identify the default gateway, right? What IP address? See, if you will provide this IP address as a gateway to user, then all user will access internet via router number 1. If you will configure this IP address as a default gateway, all user will access internet via this IP address, right? But guys, we have again protocol here between router 1 and router 2, right? That is FHRP protocol, first hop redundancy protocol. With the help of first hop redundancy protocol, actually FHRP is a family, right? There are multiple family members like HSRP. In the switching we will learn this protocol, VRRP, right? Then GLBP. So what we will do, with the help of this protocol, we will create one virtual IP address with the help of these two physical IP address, and that virtual IP address will be default gateway for all end devices, right? So router itself is going to decide who will be the active default gateway. One will be active, one will be in standby, or we can perform the load balancing, right? Maybe for VLAN 10 I can configure router 1 as active and router 2 as standby, but for VLAN 20 I can configure router 1 as standby and router 2 as active. So what is this? This is load balancing, right guys? Traffic distribution. So which routing protocol you are going to use here between ISP and your edge router? BGP. Any doubt till here, guys? Any sort of confusion till here? Anything? Anyone? For a small business, you have single homed. For medium-sized business, you have dual home. For large enterprises, you have multi-homed. And for data center or for critical applications, you have what? Dual multi-homed. For now, see, data center design is going to be, guys, bit different, right? Now whatever design we are learning in the OSPF, in the EIGRP, in the BGP, in the switching, those are for headquarter and branch offices, not for the data center. For data center we have separate devices. Like on Google you can search Cisco 9300 series devices, right? You can search Cisco 9500 series devices. So these devices are for data center. In data center actually we will have two tiers design, right? Leaf and spine design, right? We will have some spine devices, we will have some leaf devices, right? And there are many other technologies for data center like VXLAN. You are going to understand VSS. So first in the switching module you are going to learn how to combine two physical link together if both are belongs to same switch. Like you can see both cable are connected with same switch, switch 1 and switch 2. In the data center you will learn how to connect how to combine two link together if they are connected with different switches. Like you can see this port is connected with different switch, this port is connected with different switch. So how here I will configure the Ether channel, right? So design will be a bit different in case of data center. Don't worry, at the end of the training I will show you design of data center as well, right? First understand the design of headquarter and branch offices. Clear? No question? Can I move? Leave those are not for you for now. Now, how BGP? Okay. So why BGP is clear. What BGP? Sorry, not what. Where to use BGP is clear. Fine. Yes or no? Bezad.
Sir, how about in cloud, please?
Cloud.
Yes, just asking, please.
what you are asking means your question. Let me know your question first.
Yeah, I mean, can, for example, providers also they use BGP protocol or no? Please, thank
Yeah,
you.
definitely yes. Guys, the difference between running something on our server on server in the data center on the headquarter or running something on the cloud. What is the difference? Both are same, brother. Only the difference is you don't need to purchase the physical hardware, right? Let's suppose
So
I am going to host one application, right? Let's suppose gaming application. So what I have to do, bro? I have to purchase one physical device server. On that server, I will host the application. Now, I have to keep that server in a separate room where I need what? Cooling. Where I need what? Maintenance. Where I need what? Engineer who will be troubleshooting it. 24 by 7 power. 24 by 7 internet connectivity. And like this, let's suppose you have multiple applications, right? You need multiple servers. And for now, just suppose on this server you are running a Windows operating system, Windows, right? On the Windows you have installed this application, this gaming application. Now you need to host one more application that is on the Linux, on the Linux. So you are going to purchase the another hardware to run different operating system. Am I right? No. What we can do, see, we have another technology that is virtualization. What we can do, we can install multiple operating system on a single hardware. That is virtualization. And what is cloud, guys? Hosting something on the server of service provider. See, to host an application, definitely we need a physical device. But there are many more companies who have already set up their data center, their server room. They have lots of space and they are just asking for some money to you and they will provide you a space there, right? And they are connected with internet. So you can access that space from anywhere. That is what? Cloud. To make reachability, see, here is the cloud. Actually, I have run the application. I have hosted the game application on this server. Do you think this is in cloud? No. This is also in physical server. On the physical server only, bro. But this is not your physical server. This server belongs to someone else. That is service provider, right? Maybe AWS. So definitely they need also what? Routing protocol. Then only you can access the application.
But sir, how to know that is a physical server in that cloud,
There is
in that
nothing
routing?
cloud, bro. Everything is physical only.
But you are mentioned, right? In the cloud only application is
See,
running
what I am
in the root.
saying, if you are running application on someone else servers, that is cloud for you. But they have again hosted your application on their physical server and they are providing you connectivity through internet.
But router, how to know that is? You are right. You are saying right. How to know routers are saying that cloud is running on the application other physical servers?
How router will
How to
know?
design? Yeah, how to design that router in that cloud? Other physical servers are running, right?
So means on this server, on this physical server, we can run the operating system, multiple operating system, or we can run a single operating system. If you are running multiple operating system, that is concept of virtualization. See here, if I want to install a router, guys, router iOS, can I install it? Yes, I can install the router iOS here. Like on Cisco devices, you are learning what? Cisco iOS, right? So you can download the iOS from the Cisco website and then you can compile that on this server. You can run that on this server.
This is a separate operating system, right?
Which one? This one is different
So,
from the Windows operating system or the Linux operating system, but this is also one operating system only. See, if someone else is running operating system for you, that is cloud for you, but that is also physical only. AWS has big data center, bro, big data center. They have lots of space, and for you they are running services there. For that you are paying to him, so that you cannot, you don't need to manage the physical devices. But everything is physical only. Don't worry about the clouds and virtualization, guys. We will see those things later. Please focus on BGP.
okay, thank you.
Now see how BGP protocol works. R1, R2. Between these two routers, I need to configure BGP. Let's say these two routers belongs to different company, R1, R2. I can run BGP between the company as well as within the company as well, right? This is not like we can run BGP between the companies only, right? BGP is suitable for within the ES as well as between the ES, right? So let's say here ES number is 100 and here also ES number is 100. That means both routers belongs to same company, my company. Here also I can run BGP. Here ES number is 100, here ES number is 200. That means these two routers belongs to different company. Here also I can run BGP, right? So we have two types of neighborship in BGP, iBGP and eBGP, right? In this scenario, in upper scenario, we will configure iBGP. In this scenario, we will configure eBGP. 1 minute, guys. Yeah, between 100 and 200 we will run eBGP. Now try to understand, this is very important, bro. If you will not understand the BGP neighborship, I cannot teach you the BGP protocol, right? Even no one can teach you the BGP protocol. To understand BGP protocol, try to understand how routers are going to form neighborship. So manually you have to first configure neighbor. You have to define the neighbor IP address on router number 1. See, let's say here IP address is 12.1.1.1. Here IP address is 12.1.1.2. 12.1.1.2. Right? And now on router number 1, I am going to run command router BGP ES number 100. Once I will hit enter, R1 will allocate some memory to BGP ES number 100. And now I am going to say your neighbor is 12.1.1.2. And then remote ES means ES number of your neighbor is 100. So with the help of this command, router will get to know two information. One, what is the IP address of my neighbor? Second, what is the ES number of my ES? So ES number of my neighbor is 100 and my ES number is also 100. That means which type of neighborship I am going to form? iBGP neighbor, right? But as you know, BGP is TCP based protocol. BGP is TCP based protocol. So router cannot send message of BGP directly to their neighbor. So once I will hit enter over here, what router 1 will do? Router 1 will generate one SYN message. Which message? Which message?
Sync message.
Sync message.
Hello message.
Sync message is nothing but the TCP header. What will be the source port number?
12.1.
12.1. Source port number.
179.
Post port number.
It can be either
179.
random port number or it can be 179. One router will use well-known port number which is defined for BGP. One will use random port
Random.
number. Leave port number as well for now. Okay, or let's suppose here random port number is source port number is 1025 and destination port number is 179. Then source IP address. Source IP address will be the IP address of exit interface. IP address of exit interface is, guys, 12.1.1.1. Destination IP will be what?
12.2. 1.2.
12.1.1.2.
2.
Source MAC will be the MAC address of R1, destination MAC will be the MAC address of I2. Now router 1 will forward this to router number 2. When router 2 will receive it, first of all router will receive it at layer 2. It will check destination MAC. If destination MAC will match, then it will open the packet. It will open the frame. It will check which field, type field. It will get to know that I need to hand over REST traffic to IP protocol. At network layer, IP protocol will receive the packet. It will check the destination. If destination IP address will match, then it will check the protocol field. It will get to know, okay, the upper protocol is TCP. It will hand over to TCP protocol. It will remove the layer 3 header. It will hand over to TCP protocol. TCP protocol will check the destination port number. Destination port number is 179. Now, if this service is enabled on router number 2, then it will generate what? SYN plus ACK. If this service is not enabled on router number 2, it will send the reset message. As you know, this is a process of three-way handshake. Reset message. Right? So let's say I have configured BGP on router number 2 also. So BGP port number 179 is enabled over here. Right? Router 2 is going to make one entry in their TCP table. Right? Guys, for TCP connection, routers maintain TCP table, transmission control block. Right? So in the TCP table, it is going to maintain one entry. That source IP address is 12.1.1.1, destination IP address is 12.1.1.2. Source port number 179, my port number, destination port number or port number of 12.1.1.1 is 1025 and my port number is 179. And then status. Status will be not established now. If you are troubleshooting the BGP protocol, right? Let's suppose between two companies, BGP neighborship is down. So before troubleshooting the BGP, you are going to troubleshoot TCP table. Why? Because until and unless two router will not form TCP connection, logical connection, it will not form BGP neighborship. Even it cannot share BGP messages, right? So now router 2 is going to send what? SYN plus ACK. SYN plus ACK. In the SYN plus ACK message, source port will be 179, destination port will be 1025. Now router 1 will be using this port number. This port number will be assigned to router number 1. Source IP 12.1, destination IP 12.2. When router 1 will receive the SYN ACK message, again router 1 is going to maintain this table and router 1 will send finally what? Acknowledgement. Once it will get acknowledgement, router number 2, it will put a status what? Establish. Establish. Now, if TCP connection is established, then routers are going to exchange actual message of BGP. Actual message of BGP. And again, in the hello message, like in OSPF, we have hello message. We'll see what message we have in BGP. But again, in BGP, both routers are going to match some parameters. Like here, you have defined what? Remote ES 100. So when router 1, router 2 will receive the message of BGP, right? There will be ES number of neighbor. If this ES number will not match, then neighborship will not form. So these are what? Parameters. Correct? So sometime, most of the time, in the real time, in the industry, you will be troubleshooting BGP issues between two routers, right? And guys, you know the biggest advantage of using BGP is what? Like service provider network. This is the service provider network. Lots of routers are there, right? This is one PE router. This is another PE router. Here is one customer. Let's say customer is Dell. Dell side 1. This is Dell side 2. Side 2 of Dell. And both sides of Dell are connected with PE router. PE. Correct? Now between P to P, between source and destination, there are multiple paths. Am I right? Tell me guys, yes or no? Are you getting me? There are multiple paths. So if Dell one side is advertising a subnet that is, let's say, X, it will advertise to this PE router. If this PE router will advertise X network information to all PE router, all provider router, then these all routers are going to install X network information in their routing table. Am I right? But with the help of BGP, we can form BGP neighborship directly between PE to PE. Here we can form BGP neighborship, right? So we can configure BGP with directly connected router as well as indirectly connected router. Like let's say between router 1 and router 3, I want to share 1000 number of prefixes. I can form BGP neighborship between router 1 and router 3 directly, right? Router 2 will not have route in their routing table, 1000 number of route in their routing table. And this is needed, right? Otherwise, see in the service provider network, let's say there are 1000 number of routers. So all 1000 number of routers are going to install 1000 prefixes, 100 number of prefixes of Dell. And like this, there are many companies connected with this service provider. So all routers are going to maintain huge number of routes. Right? So let's say you are troubleshooting, you are a network engineer here, and BGP neighborship is done between this router and this router. This router and this router. BGP neighborship is done. So what you will do, guys? First of all, you are going to verify the TCP connection. TCP connection is up or not between this P to P. If TCP connection is not up, that means it cannot exchange the BGP message. In the same way, in this scenario, in those scenario, here we will define neighbor 12.1.1.2, remote ES is 200. On router number 2, I will say neighbor 12.1.1.1, remote ES is 100. Let me do one thing. Let me perform on a small lab of BGP today. And from tomorrow, we will be talking about the advanced concepts like messages, states of BGP, many more concepts are there. And to troubleshoot the BGP, why you are learning BGP routing protocol, guys? So that you can work in the industry, right? And when you will be working in the industry, you will be troubleshooting BGP issues. Most of the time you will be troubleshooting BGP issues. Now let's say this is my scenario. And guys, one more thing. Between router 1 and router 2, I have, let's say, one more link here, router 3. Right? Here IP address is 12.1, here IP address is 13.1, here IP address is 12.2, here IP address is 14.1. Suppose. So if I will form BGP neighborship between router 1 and router 2 by using these two IP addresses, then what will happen? BGP neighborship will form on this link, right? And if this link will goes down, then BGP neighborship will goes down. So you know in real time how we will configure BGP in this scenario. On router number 1, I am going to create one loopback 1.1.1.1. On router number 2 also I am going to create one loopback 2.2.2.2. And I will configure OSPF routing protocol first here. What routing protocol? OSPF routing protocol. Why? To make reachability between 1.1.1 and 2.2.2. So guys, let's suppose I have configured the OSPF. Now tell me, according to OSPF, which path is the best path between router 1 and router 2? Can router 1.1.1 ping to 2.2.2 after enabling OSPF on all routers? Yes or no? Tell me guys fast, because we have very less time and I need to finish it. After enabling OSPF 1.1.1, can ping to 2.2.2 or not?
Yes.
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 Right. So with the help of this loopback IP address, if I will form BGP neighborship, then what will happen if this link will goes down? Still 1.1.1 and 2.2.2 are reachable through OSPF via lower path. OSPF will automatically install lower path in their routing table, right? So your BGP neighborship will not goes down, right? So in real time we will configure BGP with the help of loopback IP address only, right? So, and to configure BGP neighborship with the help of loopback IP address, you are going to add one more command. Like if I am saying router 1, your neighbor is 12.1.1.2, right? Then router 1 will forward BGP message with source what 12.1, right? The IP address of exit interface. But I can tell to router 1, bro, neighbor 12.1.1.2, do one thing, update your source to loopback 1. Now router will start sending BGP message to 12.2 with source IP running on loopback 1 interface, right? We'll never form BGP neighborship through physical link in the real time, guys. Like same thing in service provider. In service provider, between PE to PE, there are multiple paths. Multiple path. So this is P, this is another P. I can configure BGP neighborship with the help of physical interface, but what will happen if physical link will goes down, then my BGP neighborship will goes down. So it will be better. Here I can create one loopback 1. Here I can create one loopback 2, and I can configure any IGP protocol here, IGP, to make reachability between loopback 1 to loopback 2, and will share lots of prefixes, lakhs of prefixes between PE to PE directly, right? Because now we have BGP neighborship here, right? So I can share lakhs of prefixes between PE to PE without installing those routes in the routing table of these routers, right? And guys, between loopback of router 1 and router 2 means PE to PE, we have multiple paths and we are running IGP protocol. So if any path will goes down, no worry. Still my loopback will be reachable with each other. So let me show you how to enable BGP so that you can also practice. R1, R2, what is this? Is console visible? Config T,
Yes.
interface F0/0, say no set, and the IP address 12.1.1.1 255.255.255.0. Router 2, config T, interface F0/0, no set, and IP address 12.1.1.2 255.255.255.0. Now I am going to enable BGP. See, ping 12.1.1.2. Ping is working. Is ping working? Yes?
Yes, directly connected.
Yeah. Now, so TCP brief. Guys, see the TCP table. Empty. There is nothing, correct? That means there is no any TCP connection on router number 1. If you want to see the open port number on router, what command you can run? So TCP I think on this router we cannot see. Next class I will show you on the another router. Let me do one thing. Let me configure BGP here. Now router BGP, and before enabling the BGP, let me debug IP TCP packet. Debug IP TCP and what we can say intercept. Done. Now router BGP AS number 100 and neighbor IP address of neighbor 12.1.1.2 and then remote AS. Remote AS of neighbor is I'm configuring iBGP, so same AS number. Done. This IP address should be reachable. Neighbor IP address should be reachable from router number 1 and neighbor IP address is reachable. Correct, guys? And now see, router 1 is trying to form TCP connection. Router 1 is trying to form TCP connection. IP address of router 2 12.1.1.2, port number 179, source IP 12.1.1.1, port number random port number. Right? These are the window size, scene bit, you can see. But this router is receiving reset message. The reason port number 179 is not enabled on router number 2. Am I right? Why router 1 is receiving reset message, guys? Because 179 port number is not enabled on router number 2. Fine. Now router 2 will be using what port number? 179. Now let me take you to R2 and say router BGP, and before that here also let me enable the debugging. Debug IP TCP, debug IP TCP packet port 179. See, this router is sending what? Reset message. Send reset message to 12.1.1.1 to this port number from 12.1 with this port number, source port number 179. And so TCP brief. There is nothing. Hope you are getting me. Then debug IP BGP, and on router number 2 also I am going to debug BGP as well. Debug IP BGP. Now let me take you to R2. Config T, router BGP AS number 100 and here neighbor is 12.1.1 and remote AS of neighbor, guys. Remote AS of neighbor 100. So TCP brief. Now you can see there is connection, right? There is logical connection. Here you can see it have formed the logical connection. Establish. Status is established with 12.1.1.1. On router number 1 also status established. Now these are BGP messages. We'll not discuss about the BGP message now, leave it. But here you can see the log message. BGP neighbor is, guys, up. But before coming BGP neighbor, both router will form TCP connection on all. Both router will form TCP connection. So TCP brief, right? Status is established. Now if router 1 need to send BGP message, let's say one message of BGP is open message, right? So guys, BGP is an application layer protocol, means router 1 will generate open message at which layer? At application layer. At application layer, BGP protocol will generate open message. Open message is used to establish neighbor, right? In OSPF there are two use of hello message. In EIGRP there are two use of hello message. One, to discover the neighbor. Second, keep alive. But in BGP, guys, we have two different types of messages for these two different tasks. open message for neighbor to discover the neighbor, to establish a neighborship, and we have a separate keep alive message, right? So BGP will generate open message at application layer, then it will hand over to transport layer to TCP protocol. TCP protocol will add source port number, destination port number, right? And see which router is using random port number 12.1. Router 1 is using random port number, 12.2 is using 179 port number. Then source IP 12.1, destination IP 12.2. After that, we will forward to router 2. In the same way, router 2 will also generate open message, right? Both will exchange open message and then it will establish a neighborship. So IP BGP summary. See the neighbor information. Neighbor IP address is 12.1.1.2. This is the version of BGP, latest version. The AS number of neighbor is 100. How many messages it have received from neighbor? 6. How many messages it have sent to neighbor? Message sent 6. Right? How many prefixes it have received from neighbor? 0. Till when neighbor is up? This time. Done. On router number 2 also. So IP BGP summary. So we have BGP neighborship. Now guys, do one thing. Here I am going to block port number 179, right? Say access list 101 means extended ACL, and then deny which protocol? TCP protocol with source 12.1.1.1, destination wildcard mask of source 0.0.0, destination 12.1.1.2, wildcard mask 0.0.0, and the port number is equal to 179, equal to 179. I have blocked the TCP port number 179 and clear IP BGP star. Now so IP BGP summary. So IP BGP summary. Why still neighborship is there, guys? So TCP brief. TCP connection is still up. I have not applied that ACL on interface till now. Now on interface F0/0 say IP access group 101 direction in. And so IP TCP brief. So sorry, TCP brief. Clear IP BGP star. See what will happen now. Peer done. So TCP brief. Is there any connection? TCP connection? No. So TCP brief. These are previous entry, right? Clear IP TCP Finwit, okay. Now see BGP neighborship. So IP BGP summary. Neighbor is active. That means there is some issue. Most of the time in real time you will see neighbor is active and you will be troubleshooting this issue. How you will troubleshoot, guys? Simply you will check TCP table, right? There is no connection established. That means both routers are not able to form neighborship, TCP connection. Now what you will do, you will verify the connectivity between source and destination. If 12.2 is not reachable from router number 1, then definitely the router cannot form TCP connection. If IP addresses are reachable, both IP addresses are reachable, you are going to check what? Open port number. Port number is open or not. If port number is also open, now you are going to check what? Filtering. Is there any filtering? On so run interface fast Ethernet 0/0, yes, there is filtering. Access list number 101 interaction 1. Simply I can remove the access list. Say interface F0/0, no IP access group 101 direction in. So TCP brief. Soon it will form TCP connection again. You can see, and now again you can see BGP neighbor is up. So sometime here you will see neighbor is idle, sometime you will see neighbor state is active. And guys, if your BGP is working fine, then there will be nothing here. State will be null. Null means full. Now it have not received any prefix from their neighbor. Router number 1 have also not received any prefix from their neighbor. Now let me do one thing. On router number 1 I am going to create one loopback. Interface loopback 1 IP address 10.1.1.1 255.255.255.0. On router number 2 interface loopback 1 IP address 20.1.1.1 255.255.255.0. Guys, now try to understand how to advertise network in BGP. Do so IP BGP. This is the command to check BGP table. There is no any network available in the BGP table. Now I need to advertise 10 network on router number 1. So say router BGP AS number 100 and then network. Even you know we cannot run more than one process of BGP on a single router. Router BGP AS number 200. See, I am not able to run. What it's saying? BGP is already running. That is AS number 100, right? You can run multiple OSPF process on a single router, multiple EIGRP process on a single router, but you cannot run multiple BGP process on a single router. And this is an interview question. This is an interview question. Interviewer can ask you, can I configure BGP ES number 10 and 20 on the same router? Most of the people are saying, yes sir, why not? Of course. And now another question, another interview question. Router BGP ES number 100 and network 10.1.0.0 255.255.0.0. Will this command advertise 10 prefix in BGP, guys? Yes, tell me yes or no. Will this command advertise 10 prefixes in BGP?
No.
No. Always keep in mind, whatever prefixes you are advertising in BGP, that prefix with same subnet mask should be available in the local routing table. And even if this command is incorrect, here I have to say mask 255.255.0.0, right? Do so IP BGP. See, there is nothing in BGP table. Reason? Do so IP route. Yes, 10 network is available in the routing table, right? But the subnet mask is different. You can advertise networks like this in OSPF, in EIGRP, but not in BGP. In BGP, whatever network you are advertising, make sure that network is present in local routing table with same subnet mask, right? So here I am going to remove this command, no network 10.1.0.0 and say mask 255.255.0.0. Then network 10.1.1.0 and mask 255.255.255.0. Now do so IP BGP. Now you can see it have installed 10 network in BGP table, right? And there are two symbol, guys, star and greater than, right? We'll discuss about these two symbol, and these are attributes. Wait, attribute metric. Next hop IP address for self-advertised prefixes. Next hop will be always 0.0.0. Now router 1 have installed this network in their BGP table. Now it will advertise this network information with their neighbor. Do so IP BGP summary. Do so BGP summary. Who is neighbor? 12.2. So it is going to advertise this network to their neighbor. Now on router number 1, so IP BGP. Yes, you can see router 2 have also install this network in their BGP table. And this network is best as well as valid, so it will install it in the routing table as well. So IP route BGP, you can see, right? And so IP BGP, even here you can see, sorry, so IP, so BGP summary. Here also you can see it have received one prefix from their neighbor, from this neighbor 12.1.1. Hey brother, please mute yourself if you are not speaking. Is class boring, guys?
No,
No.
sir. No. Sorry for that disturbance.
Done. So what router 2 is saying? I have received one prefix from this neighbor from 1.1.1. What is that prefix? So IP BGP, this one. Next hop IP 12.1.1, right? So can router 2 ping to 10.1.1 now? Yes, ping is working. And in the same way, I can advertise 20 network on router number 2, router BGP S number 100 and network 20.1.1.0, mask 255.255.255.0. Again, in BGP, we have multiple options to advertise network, right? This is the first option. We'll discuss more options as well, right? Now, so IP BGP, you can see it have installed 20 network in their BGP table. And now guys, in the BGP table, interviewer can ask you how to check self-advertised prefix. So see, for self-advertised prefix, next hop will be what? 0.0.0, right? That means this is self-advertised prefix and this is received prefix. Even I can check the received prefix. So IP BGP neighbor 12.1.1.1. So I am asking, please show me the BGP table for this neighbor, and for this neighbor only received route. Show me the received route, how many route you have received from this particular neighbor. Inbound soft reconfiguration not enabled on the router. Very good. Router BGP S number 100 and neighbor 12.1.1.1. And here I can say what? Soft reconfiguration inbound. Yes, now I can run the command. So IP BGP neighbor 12.1.1 received route. So it's showing, see this one only, right? Even if you want to check self-advertised prefixes on router number 2 only, what I can say, so IP BGP and include 0.0.0, it will show you only self-advertised prefixes. These are the interview questions, guys. And trust me, BGP is my favorite routing protocol because I have worked in many organizations on this routing protocol. So I am going to teach you completely real-time scenario here only, right? We'll tell you around 100 interview questions of BGP. And even if you will go for interview today, right, definitely interviewer will ask you few questions from this routing protocol, BGP. Every time interviewer is asking question from BGP protocol, right? So the BGP classes are very important, right? So that's why requesting you to pay attention, guys, for next 1 week maybe, or for 4 to 5 classes only. We'll finish everything. Today we have covered why behind BGP and where to use BGP. Then we have seen basic configuration of BGP between two router and which type of neighbor it is, iBGP. How to verify that? So IP BGP. So IP BGP neighbor 12.1.1.2. Show me the detailed information of this neighbor. So what it's saying, bro? Internal link, right? Neighbor BGP neighbor is 12.1.1.2, remote AS is 100 and link is internal. BGP version is 4 and the remote router ID is 12.1.1.2. Router ID is exactly same like OSPF, right? Both router will elect one IP address as a router ID. If there is no loopback, then it will check the physical. If there is loopback, then definitely it will select the IP address which is running on loopback interface as router ID. If there are multiple loopback, the higher IP address on the loopback will become router ID. So BGP state is establish. While troubleshooting, you will be checking this state only. right? If there is issue with BGP neighborship. We will discuss the BGP state. We have multiple states in BGP. How BGP neighborship can stuck in active state, in idle state, right? But this time BGP state is established and neighbor is up. From when neighbor is up till 8 minutes 41 second. Hold on time, keep alive interval, right? After every 60 seconds it is sending keep alive message. Done. Now here you can check the messages for the particular neighbor, like how many open message it have sent and received. 1. Router will send open message only to discover the neighbor, only to form the neighbor, right? Once BGP will form the neighborship, it will not send any open message, right? Because we have separate message that is keep alive to track the neighbor. Guys, size of keep alive message is very small as compared to hello message of OSPF. That's why here in BGP we have divided the hello message into two messages, open and keep alive. How many notification message it have sent to their neighbor? 0. How many notification message it have received from the neighbor? 0. And guys, notification message is very dangerous message of BGP, right? Even
Sir, why?
why it is dangerous?
Yeah, please.
Not now,
Thank you.
right? Even guys, we are, whenever we are seeing notification messages while troubleshooting, right, we hate to see these types of messages, right? Then how many update message it have sent to their neighbor? 3. And how many update message it have received from the neighbor? 2. How many keep alive message it have sent? 9. How many keep alive message it have received? 10. Route refresh message? 0. Receive? 1. Total number of messages that this router have sent to this neighbor is 15, and it have received from this neighbor is 14. Right? Address family for this particular neighbor is IPv4. Another address family is IPv6. Session done. So these are the detailed information of neighbor. Okay, and so IP BGP here also you can see 20 network is there. For self advertise 0.0.0.0 and for received dot, this is the next hop. For received dot, there is one more attribute that is local preference, but for self advertise prefix, local preference value is 0. Again, this attribute will work only for iBGP neighbor, not for eBGP neighbor. Don't worry about the attribute, we will see it later. So guys, this was very basic about the BGP. Tomorrow we'll start the BGP maybe messages, types of message in BGP. We have open message, keep alive message, update message, notification message, and route refresh message. Here also you can see the all messages. Open message, notification message, update message, keep alive message, and route refresh message. So you need to learn these all types of messages, and tomorrow we'll focus on this only. Then we'll see the content of each message, like open message, what are the parameters for neighborship in BGP. We'll see the concept of next hop. Then definitely in each routing protocol, first we are talking the loop avoidance mechanism, like how routing protocols are going to avoid the loop. So we'll see how BGP will avoid the loop. So tomorrow maybe we will try to cover multiple topics. Okay. Now if anyone have question from today's session, please ask. Otherwise, that's all for today.
Sure. Just a question, please. Whenever we are speaking about the open message, it means TCP or totally different?
The open message is a message of BGP, brother. This is a message of BGP, not SYN message. SYN message is message of TCP protocol. That is different protocol. BGP is different protocol, right? BGP
Right.
uses TCP service at transport layer, right? As you know, all application layer protocol will either use TCP or UDP at transport layer, yes or no? So BGP
Right.
uses TCP. All reliable protocols are using TCP at transport layer, and BGP is a reliable protocol.
Correct. Thank you.
Yes, anything else? Then I am sending you recording, guys. Let's meet tomorrow. And please configure this lab by yourself. I will be sending lab as well. Some lab of BGP that you have already study material. Review the basic concept of BGP. And then let's meet tomorrow. Yes or no?
Yes. Also, sir, if you don't mind, kindly also share the PDF about the BGP earlier you
Which
showed.
PDF? You have already that
About
PDF,
the-
bro.